Hey guys, I'll be right back. Let me get some more students in here. Okay. Alrighty. Guys, welcome. Hello. Hey Archer, sorry about that. Yes, I had a good weekend. Lots of diapers. How about you guys? Did you guys have a good weekend? Nice. Did anyone ever end up playing some of that game with the plus and minuses? Oh, can you hear me okay? Nice. Did you guys figure? I haven't thought of any strategies, but have you guys? Has anyone come up with any strategies for that game? I think there's got. I haven't looked into it, but there's got to be like like tic tac toe. You can always. Oh, negatives always wins. Huh. Okay, maybe. Or I see. Okay, yeah. Well, that's something to investigate. Yeah, I don't know. Um, I would be surprised if negatives has an advantage because it seems like actually maybe I'm not surprised. Maybe that makes sense. Yeah, I don't know. But yeah, if you guys, if anyone wants to come up with a theory of that game and see what like the best first move, I'm always happy to hear any ideas. Okay, so let's go over some questions. If you guys had any questions in the homework, I'm going to just share my screen here. And I'm thinking to do, our next test will be on this coming Tuesday. And tonight I will post a practice so that you guys can review it, and maybe we can go over it tomorrow. And the practice test, you'll see, is like really similar questions to what we've seen, really similar questions to what we did last week, basically. And if there's anything on there that we haven't covered, we can cover it carefully this week. Oh, I have to install something. Alrighty. Share screen. Okay. So I got a few questions here. Very good. Let me see. Oh, this is other stuff. Okay, so Archer, what section was 45, 47, 77? What was that, 8.3? Okay, 8.3, 45, 47, and yes, I will post the actual day of the test tonight, so this way everyone can see it, and it'll be scheduled in the classroom. 45, 47, and 77. And then 8.1, 13, 19. 13 and 19. And 8.2, let's see here, 8.2, 8.2, 21, and 73. Okay, so let's go over a few of these. And I think, and then tomorrow, so for tonight, for homework, 13 and 19 were 18.2. Oh, okay, 8.2, sorry. Okay, let's look at 8.2. And if they don't look like they're going to be super relevant to the test, I might just, 2177 were in 8.3. Okay, cool. Got it. This is 21, and then 8.1 was 73. Okay. Okay. Let me go over these. If anyone has any other questions, you're always welcome to ask. 8.1, 73. Okay, that's just example 44 graphically. Um, 73 and 8.2. Okay. So 8.1 is about the, so I'll do this first one, 8.144, which is 8.144, which is from 73 to solve. It says solve 44 graphically. It says a non-toxic polish. So it says mix, it says we want to mix mineral oil with vinegar. And to make a 16-ounce batch Jasmine uses amount of mineral oil that is 4 ounces more than twice the vinegar. Okay. So the question is, how much of each is required? So this is a nice system of equation setup, and it's also combined with, like, one of these standard converting English into math equation type of problems. How much of each ingredient is required? Okay, can anyone tell me just the setup that I would look for? Of course, you can solve this maybe just by looking at it by guess and check, but can anyone tell me kind of just, I want to make sure that everyone's on board with the setup. So either message me, or you can raise your hand, I'll call on somebody. This way we can, I got some students here. Yeah, if anyone wants to volunteer and kind of share how they would set this up, or just message me if you message me your variables and the 2 equations that you would use to solve it. And here I don't really care too much about the solution. The solution is really easy to solve for, but I just want to make sure that you're on board and you're comfortable setting this one up. Oh, this was 8.173 said to solve 44 graphically. So that's why we're doing 44. And we don't actually have to solve it graphically. Let's just draw a picture to do that. But I do want to see everyone set it up carefully. Nice. I got one good equation so far. All right, one student answered. I'd like to get maybe like a few more people to tell me their setup. So you have 2 types of ingredients, the mineral oil and the vinegar. And you want to make this batch, a 16-ounce batch. And they give you a condition, and focus on the word is. So, and kind of what are your unknowns? Let me see. All right, let me, so I'm gonna just ask some people, let's see here, who's, anyone want to jump in here and kind of share their idea? And it's okay. It's actually really good if you're not 100% sure. Anyone who's not 100% sure, just want to kind of walk through it with me, how to set it up. Nice. Savannah, can you would you mind sharing kind of what your idea was? You did a great job.
Sure. So the equations I used were 2x plus 4 equals y, where y equals mineral oil and x equals vinegar.
Nice. And one little comment, and this is like a really small detail, but make sure you write amount of mineral oil. It's like a really tiny thing, but it's going to be important for other problems, you know?
Okay.
X amount of vinegar. Excellent. Okay. So
And then, sorry, and then x plus y equals 16. And then I solved using substitution.
perfect. I like it. All right. Yeah, you can plug in for substitution would be a great approach. Anytime you just have one variable by itself, it's always nice to do substitution. So we can do x plus 2x plus 4 is equal to 16. So we get 3x is equal to 12, or in other words, x is equal to 4, and y is equal to 12. All right. Those of you who just entered, I saw a few students just entered. Our next test will be on Tuesday, and I will post the practice tonight so that you guys can look it over tonight, and we can go over it tomorrow and Thursday as well. Okay, great job. Thank you, Savannah. That was awesome. Let's do 8.2. Let's look at some of those examples. 8.2, 13, and 19. 8.213, here it was 3x plus 5y is equal to 3, and x equals 8 minus 4y. And it says to solve using substitution. So for substitution, we can just, sub in. We have x by itself. So let's just put it in for the x in this equation, replace that, and solve for y. So we'll get, and the key when you're doing substitution is to do parentheses. So 3 times 8 minus 4y plus 5y is equal to 3. Multiply everything through, you get 24. Oh, okay, cool. Minus 12y plus 5, y equals 3, and then you can solve from here. So I won't finish this up, but just be careful with your arithmetic. If you make some small arithmetic error on the test, as you saw last time, I'm not going to penalize you too much. Maybe just like a small fraction of a point. It's really what I'm looking for. I want to see the correct setup. That's the most important thing for me. Okay, let's move on. Let's take a look at number 19. So this one asks to use the substitution method, even though it's set up like a elimination problem, because everything is written in standard form. So 8.219, but you can always use any method that you want. You just have to rearrange stuff if you want to use the other method. So this is negative 5 s plus t is equal to 11. And this is 4s plus 12t is equal to 4. All right. So how can anyone tell me, either through chat or you can raise your hand, which term should I try to move set by itself in order to do substitution? Probably this, if you just saw this, you would probably want to do elimination because it's set up in standard form. But if you wanted to do the substitution, which the question asks for, what would be the easiest thing to do? Nice, Lily. Nice, Hannah. Excellent. Hannah, do you want to suggest, say what you suggested?
Move 5s to the other side.
Awesome. Yeah, I like that. So just rewrite this as t equals 11 plus 5s. And then you can plug that in for t. Here's t, orange, and just plug it in for this t. And remember your parentheses. And so I'm not going to finish this one all the way through, because now it's just kind of doing a little bit of tedious arithmetic and algebra. So 12 times 11 plus 5s is equal to 4. And just have to remember to distribute it, and you can get s. What would that be? I mean, what's 12 times 11? Is that 132? So this becomes 132. When you combine everything, I think it's 132 plus 64s equals 4. Okay, it's not too bad. Then you get 64s equals negative 128. Dividing everything by 2, you get s equals to negative 2. And then you can plug it back in and you get t. I think t equals 1. All right. Okay, let's move on to some other questions from 8.3. Oh, there's 73 as well. 73, that was, I'll post that one. That was, I think we covered that one in the notes last time. Yeah, let me see if we did that one. No, I don't want to review. No, it's a different class. Yeah, so this one was in the notes. So I'll post these. I'm not sure if I posted it yet, but you can review that one there. Okay, let's look at 8.3. Let's look at some questions from here. So these were kind of definitely practiced the examples and stuff that we did in class. Okay, so I don't remember if we did 45, but we can always, it's always good one to review. So this is 8.345. So so the train leaves my favorite city, Danville, and travels north at 75 kilometers per hour. And then 2 hours later, I believe we might have done this once. Looks the 2 hours later thing reminds me, but let's do it again. 2 hours later, an express train leaves at 125 miles per hour. How far from the original station do they meet? Okay. Oh, 21. Oh, sorry. That was in 8.2. Oh, yes, definitely. I'll do 2173. So that one. Okay. Yeah, sorry, I skipped 21. Okay, so so we have 2 trains leaving the station. Let's make our table. And the trip is until from when they leave to when they encounter each other. So we have train 1, train 2, distance, rate, and time. Okay, so what's something super easy we can fill in with this problem? What's kind of the easiest thing you can plug in? What do we know about the first train for sure? Nice, yeah. Nice, Archer. Yeah, we know the rate, right? So we know that this first train is 75 kilometers per hour. And you can just put in 75. And in fact, we also know for the second one. All right. Are we given any information about what the distance is or what the time is for the first train? And I like to go kind of trip by trip or train by train.
We're given that the second train leaves 2 hours later, so it'd be t minus 2.
Nice. So the first train is just t, or like t sub 1 for the first train. And then Lily suggested to make it t minus 2 for the second train because it's 2 hours later. That's really good because you don't want to use too many unknowns. If they tell you that there's some things are related, like something left a little bit later, you can adjust it using a variable that you already have. Okay, and then Lily, what about the distances? What should we set up for that?
Just the same distance because they're leaving from the same spot.
Exactly, and we're waiting until the moment that they meet. Perfect. Okay, now this is 2 equations, 2 unknowns. And sometimes with these, they're really nice to solve because you can use substitution if you want. So we plug that in. We get 75t equals 125t minus 250. Add 250, subtract 75, you get 250 equals 50t. So we get that t is equal to 5 hours. And then plugging in to find the distance is equal to 5 hours times 75 kilometers per hour. And then 5 times 75 is, what would that be? 5 times 75 is, 5 times 70 is 375? Okay. Does anyone see another way without setting up a system and without doing kind of all this? This is not, I wouldn't say this is too complicated of like problem solving, but without like really needing to write anything down. Can anyone come up with a good argument to justify, wait, did I do everything right here? 75, 125, it's going 50 kilometers per hour. Oh, 1, 2. Oh, yeah. Yeah. Can anyone come up with a slightly different explanation of this without necessarily having to solve equations, just by looking at it? Because a lot of times these problems, they have like nice little shortcuts that you can use to, especially if the numbers are nice, that you can use to solve without doing any equations. Just, I don't, like, you don't need to know how to do it that way, but it's nice to see another approach. Anyone have any ideas? I kind of mentioned the idea a little bit a few classes ago. So let me ask a few questions. When the second train starts to move, what's the head start that the first train has on the second train?
Two hours.
Nice. In terms of distance, how far away is it? It ran for 2 hours. Nice. It will be 150 kilometers, right? Okay, so it's 150 kilometers away. Now, imagine that that train is staying still. Like from the perspective of the first train, how quickly is the other train gaining on it? Because it's going faster. They're both kind of like, imagine two things on the highway. One of them, they're both moving forwards, but one of them, the one that's in the back, is moving faster than the one that's ahead. From the perspective of the one that's ahead of the first train, how quickly is the second train gaining on it? What do you guys think? So if I'm traveling at 75 kilometers per hour and I see somebody behind me driving at 125 kilometers per hour, from my perspective, how fast does it look like the guy is getting closer to me? Like, or if you're driving at 60 miles per hour and you see somebody behind you at 80 miles per hour, how fast does it look like the other guy is going towards you from your perspective? What do you guys think? You're going at 60, you're driving forward, and then behind you, somebody's speeding towards you at 80 miles per hour. Or they can even pass you. When they pass you, just from your perspective, like if there wasn't any road or anything around you, and you can even tell how fast you're moving. From your perspective, you're not moving at all because everything around you is white. Or like just like a vacuum or whatever, there's nothing around you. And you just see this other car. How quickly does it seem the other car is moving? If you're moving 60 and they're moving at 80 in the same direction, what's the relative speed to you? So you're going 60, they're going 80, it would be 20, exactly. It looks like they're going 20 miles per hour. It's the same thing if you're going at 60 miles per hour and then somebody pulls up to you and they're also going 60 miles per hour, then you guys can even have a conversation like next to each other. You shouldn't do that, but you could theoretically like just drive side by side and it looks like relative to each other, you're not moving. What if you're going 60 miles per hour and you see somebody coming at you the other way at 80 miles per hour? From your perspective, and this is really pronounced when you're on a train, especially on the train that goes by the highway sometimes, if you look at the other cars, how fast, like if you're going, let's say you're on the train at 60 miles per hour and there's a car coming the other direction at 80 miles per hour, how fast does it look like that car is going towards you? Like what's the illusion? Or what's the relative speed of the car? Nice, you add them, exactly, 60 plus 80. So when you go in opposite directions, your relative, like one person's relative speed to the other, you add them because the distance is shrinking really, really quickly. But if you're in the same direction, you can subtract your speeds. So let's go back to this train problem. Relative to train one, like if train one is standing still, from the perspective of somebody on train one, how fast is train two getting closer to train one? How fast does it look like train two is gaining on train one? What's the speed? If train one is going at 75, the other train is going 125, it's going 50. you can do subtract the two speeds. So train 2 is gaining on train 1. Train 1 starts 150 kilometers away. Therefore, to close that 150 kilometer head start, they're both moving forward. But to close that head start, that's when they're going to meet up. It's going to take 3 hours from the time that train 2 starts to move. It's going to take 3 hours to close that head start, because the relative speed is 50 miles per hour and the initial distance between them is 150, and every second that goes by, or every unit of time that goes by, that gap is shrinking because train 2 is faster. So it takes 3 hours of train 2 to close that gap. Therefore, what's three hours of train 2 traveling? That would be 3 times 125, which is what we got, 375 kilometers. You could also do it with the other train, but you have to remember that the first train, you have to account that it travels for a total of 5 hours because it traveled for 3 hours after train 2 moves, and it started also the original 2 hours of just moving by itself. Okay, please hit yes if that explanation without doing any system kind of made sense. And once you see this idea, you can apply it to actually a lot of these distance problems. I don't recommend doing it that way, especially on the test. I want you to do it like maybe make a table or a system. But in general, it's a very powerful idea to have in physics, like to simplify. If you have several moving objects, you can simplify by just thinking about the frame of reference of one of them, and then that would kind of create less unknowns. And hit no. The shortcut was just to not write anything down, but rather think about the relative velocity or relative speed of the second train, and observe that, okay, they have a 150 mile head start. The relative speed is 50 miles per hour. Therefore, it takes 3 hours to close the gap. So traveling at 3 hours for the second train is going to be 375. So it's not, you don't really save, like the steps are really the same, but it's just kind of nice to think about. You don't need to really write stuff down too much to do that one. Do it that way. Okay. I think that I wouldn't say, maybe I shouldn't say it's a shortcut. It's just a different perspective. It's the real idea there is that the algebra or the arithmetic can be simplified if you consider the problem from the perspective of a single train, and then these ideas of like meeting each other is just like, it becomes as easy as you don't need like multiple equations. You could just say, okay, when do they meet each other? Well, I have to travel 150 kilometers and I'm going 50 kilometers per hour. How long does that take? So that just becomes like one really simple equation, one dirt equation versus like two complicated situations, or two separate situations that you have to solve. And we'll try to, if we see another one, I always like to kind of think about this alternative way of doing it as well. Okay, let's do number 21. 8.3, number 21. Let's take a look at that. Oh, college credits, okay. So each course is either 3 or 4 credits. And there's going to be one just like this on the test. So it shouldn't be very surprising. Each course is worth either 3 or 4 credits. The members of the swim team take 48 courses that are worth 155 credits. How many 3-credit courses do they take? And let me make it a little bigger. And how many 4-credit courses? Okay, so this one is really similar to, we might have even done one similar before. If you have remember from seeing it, just do it again. I want everyone, I'm gonna ask everyone to, on this question to message me 2 things, or you can do it in one message. First, clearly define your variables and do it in like with every pedantic detail, like the ones like where I say the amount of, I want to see those words like written out explicitly. And then tell me the system of equations that you got and making sure that you can justify the system. And maybe just, so I want everyone to write here. And if I don't see someone write, I'm going to ask you guys and write it just in one chat. So write it all in one chat. So I'm just going to keep track of who's writing here. And if you don't chat, if somebody doesn't chat, then I will have to call you out, and we'll go through it together. Okay, so please write into the chat the answer, the setup for this problem. Just write a few sentences. Tell me what is the, and you can just separate it with a comma. You don't have to hit enter. What are the variables you're using, and explicitly what do they stand for? Like write a little sentence, and then the 2 equations that you would use. All right, you guys are doing great. Nice. I'm happy that I'm seeing a lot of students carefully write the descriptions of the variables. I know it's, for some reason, I think it's a really important detail to focus on. Oh, by the way, did you guys see one of our classmates, one of your classmates was in the news? Can I? Well, I'll let your classmate share. Okay. Awesome. Let's see, 3, 2. So make sure you don't forget the phrase number of, because I'll be looking for that on the test. All right, looks like you guys are, a lot of you are ready to ace, ace the test that's coming up. That's really good. Excellent. Okay. So I'm just going to write here. Anyone want to kind of just share what they got? So it's not just me talking. Nice. All right, you guys did great. So, okay, I was looking for this. X equals, make sure to write this number of 3 credit courses. Don't just write 3 credit courses, write number of. Because, you know, I've seen people write X equals 3, Y equals 4, and just get really mixed up. And we see that with the concentration problems as well. It's really important for those problems. Y equals number of 4 credit courses. And now our 2 equations are the total courses, X plus Y is equal to 48. This stands for total courses. And 3X plus 4Y is equal to 155, which would represent total credits. You don't need to title the equations, but it helps so that you can really believe and justify to yourself what it means, what each equation represents. And now, yeah, we can just do elimination here. Multiply everything by 3. We'll get 3x plus 3y equals 3 times 48 is going to be 144. And then you get subtracting them, the 3 x's will cancel. So just put a minus on everything on the outside. You get y is equal to 11. And therefore, x would equal to 37. All right. Okay. Any questions on those examples? Okay, let's do maybe like a 3-4 minute break just to grab a cup of water. And I'll meet you guys back like 3-4 minutes. Sorry about that. Thanks, Evan. Yeah, so one student asked, does it matter if you set Y as 3 credit courses and X as a number of 4 credit courses? That's totally fine. As long as you define your variables, I'll be able to understand what you wrote. Let's take a look at the next question here, 8.3, 21, let's do 47. I'll do 2 more problems here. This is a good one. And this one also, a similar one will be on the test. So this is canoeing, and I'm curious if anyone actually got to set it up. And we'll try to work through it together. Kayla, so this is 8.3, number 47. Kayla, so Caleb paddled for 4 hours. With a 6 kilometer per hour current. So this is going to be very similar to the airplane problem. For 4 hours with a 6 kilometer per hour current, where are we? To reach a campsite. The return trip took 10 hours. What is the speed of Kayla's canoe in Stillwater? So if you haven't had a chance, I'll give you guys a few minutes to think about it. Message me if you don't know where to start, or message me if you got it. I do want to hear if you got it on the homework and it made sense to you. Message me as well. I'd like to know who solved it um, so a good place if you're stuck is to try to do the table. So I'm messaging students hints if you message me and you're not sure at all where to start. Several students are letting me know that they're not sure where to start, and can be a little bit confusing, and I totally agree. So first, let's identify. Is this a Head Start problem, like the one with the train? Is it a collision problem, like where do they meet? Are they coming at different speeds, and we want to see from different spots, we want to know where they meet? Or is this something about a round trip, but there's a current involved? And each of those problems has you can use a table, and it's good to know kind of what category each of those looks like. So let's make the table. I don't know why I made it so big, but distance, rate, and time. And this is trip 1. This is trip 2. Okay. Anyone who messaged me that they were a little bit stuck, what is something that's you can plug into this table, no questions asked, like something really easy you can plug in? What's given to us straight ahead? The time, right? So what's the time for trip 1? Nice. We have 4 hours here. We have 4 hours. And for trip 2, we know that it's 10 hours. We don't know the distance, right? So that should be an unknown for trip 1. Now, once you write in a letter for trip 1 for distance, it's nice to think if there's any connection, and this depends on the type of problem. What type of problem is this, and what can we say about the distance of trip 2 related to the distance of trip 1? How are they related? This is not always the case, but in this type of problem, there's something nice that happens. How are the distances related? Exactly, they're the same. A few students messaged me saying they're the same because it's there and back. So it's in effect, it's very similar to like a catch-up problem where like they're both meeting up. They start at the same spot, they're ending at the same spot. Here it's a round trip because you're going back and forth. So that's a nice thing to know about round trip problems. Okay, the rate part is where it's a little bit tricky. And this is where it helps to have seen this type of problem before. What is the question actually asking us for? This is where we need to really kind of focus on what the question is asking us. What is the real unknown here? I wouldn't say, you could say the average, but it is, yeah, it does turn out to be the average. I'll explain why I'm hesitating with that later. But what we want to know is the actual rate of the canoe without any current. This is what we want. So let's say R is the rate, the true rate in still water. And once you kind of see the setup, it's the same for for all of these problems with a current or a wind, something like some headwind or tailwind or current going with the current against the current. And it's the same thing that we talked about at the airports with those escalators, with those treadmills. So if the current is 6 miles per hour, for trip 1, what should I plug in for the unknown rate part? Is trip 1 helping? Is the current helping her or hurting her for the first trip? And you do have to think about kind of what the situation is. What do you guys think? What should I write in for this box right here? Aiden, nice, it's helping, right? So therefore, what expression would be good to write in? If it's making her go faster? Nice. We would do r plus 6. And over here, we would do r minus 6 because this is the longer trip. So this is with the current, and it might help also after you think about the time to just write with current, and then this one would be against the current. Okay. All right, great. Now we can just write down these two equations, two unknowns, and we can solve it. So we have d is equal to 4 times r plus 6, and we also have d is equal to 4 times r minus, oh, not 4, sorry, 10. This would be 10 times r minus 6. Setting them equal to each other, we get 4r plus 24 is equal to 10r minus 60. And then adding over the 60, we get 84. 84 is equal to 6r. And this, let's see, 60. Yeah, this looks like r is equal to r is gonna be equal to 14 kilometers per hour. Okay. All right. Please give me a thumbs up or yes if you're comfortable with what we did, and also raise your hand or message me, hit a no if you have any questions about these steps. Awesome. Any questions? Okay, let's move on to what do we do? So we just did, I want to move on to number 77, I believe. What did, I just did 21. Let's look at 40, we just did 47, and let's look at 77. And then Archer also asks, okay, so one student asked here, how do I form these equations? Which equations? Is it, are you talking about these two equations? Okay, great. These two equations are really important to know where they came from. They came from the dirt table. The dirt table tells us that in each row in the dirt table is an equation. So that each row is distance equals rate times time. Did that help explain where those equations came from? I switched the 4 and the r plus 6 though, but whatever, it's the same thing. Yes, one student made a comment that it's hard to understand when to do what. And I totally agree with that. It helps to, there's not too many different examples though. There's like only like 3 or 4 examples of these distance problems, like these dirt problems. And just kind of, you can even do the same example a few times. Just look at it again tomorrow or look at it again later today, you know, and just try it again from scratch and make sure you're not just like memorizing a process, but you can justify why you're doing it and why it's set up a certain way, like what the meaning behind it is. And I think, yeah, I think with practice, hopefully you'll feel more comfortable with it. And the practice midterm that I'll post will be a great thing if you're already not very comfortable. I think it'll be a great chance to get more practice. Okay, let's take a look at number 77. And what was the other one somebody had there? Ah, okay, maybe we'll do 35 later also. So this is 77. Grady station wagon. So the station wagon gets 18 miles per gallon. 18 miles per gallon. And mileage is a little bit weird, right? It's like it tells you how far a gallon of gas will take you. In city driving, so city driving, it doesn't get you, is not the most efficient because you're stopping and starting a lot, so that's not the best way to drive if you want to save gas. And 24 miles per gallon in highway driving. So here they tell us the car is driven 465 miles on 23 gallons. So how many are city miles? And how many are highway miles? And this is a great little problem to practice kind of things with miles per gallon, with mileage, and also these systems of equations. And also kind of making, probably for many of you, you probably haven't seen this type of problem. So it's also good to always approach something that you probably might have not seen before, but similar to what you've seen in the past. Anyone have any thoughts how we could approach this? Nice. Lily, do you want to share kind of your idea for the setup, just for the variables?
So I was thinking X is miles in city and then Y is miles in around the highway, I guess.
I like it. That's always nice. Like, just read what the question is asking for. That's a great place to start with like your variables. So miles driven in the city, and Y would be miles on the highway. Okay, based on that, what is like the easiest equation we can write down? There's one equation that you don't really need to know much. You can just write down right away. Nice. Aiden, do you want to share what you wrote?
I said X plus Y equals 465 miles.
Perfect. Yeah. The total miles is 465. So you take the miles in the city plus miles in the highway. Okay. So X plus Y equals to 465. This is total miles driven. Okay. The next one is a little bit tricky, but it's not that bad if you're thinking very clearly. What's the other really valuable information about the overall trip that we need to use? There's one more piece of information. Nice. Gabrielle, what did you write?
What?
Oh, what did you suggest? Can you share what you wrote? That
Oh,
was
I
really,
said the 23 miles.
23 gallons.
Gallons, sorry. Yeah, that.
Perfect. So that's the total gas that we use, right? Can you think, and so that's going to be a key part of the next equation. Can anyone come up with an equation that will, and this is where it gets tricky. You really have to think clearly about mileage. So mileage, let me ask you guys this. Or actually, let me just ask the volunteer in the class. Do any of you guys drive, have cars, or starting to drive? Hey, yes, if you're starting to drive, and you know anything about your mileage. Nice. Archer, what kind of mileage do you get on your car? Do you know? Oh, yeah, nobody drives it anymore. Allison, what kind of, do you know what kind of mileage you get on your car?
No, but I don't think we can do mileage.
Oh,
Okay, I'm Allie's sister, and we share the same car because our mic isn't working. But we get really bad mileage.
nice. What kind of car is it?
It's a Lexus. It's like a 2001 Lexus. It's super old.
Uh-huh.
It's a GS 350. No, yeah.
Is that a like a bigger like SUV or
No,
like,
it's a small car.
small car? Okay. Do you know roughly like what kind of mileage it is?
I cannot say. It's really bad though. It's like definitely below average.
I see. Let me see here. How would you go about like? How do you measure mileage? How do you what is that measured in?
I measure in how much gas is burned. Like we drive, like we share my parents' car too.
Uh-huh.
So we haven't been driving the Lexi at all, like too much.
Nice.
So, but it's like we filled it up like a week ago and it's almost out and we don't drive it that much. So
Oh yeah, that makes sense. I have an old Volvo. I call it the Vo, and it also is the same thing. Like I just do a few errands and it's almost on empty. Exactly. Archer says it's the distance per gallon. It's like how far can 1 gallon take you? So in other words, you might hear like, I don't know if any of you have ever had a Prius or driven in a Prius. Like most cars are like 15 miles per gallon or 20 miles per gallon is like pretty normal. Maybe 15 is pretty low. Nowadays it's more like 20 miles per gallon. But like the Prius, you know, it was a big deal when it came out because it made your mileage be much, much better. And with 1 gallon, you could go, instead of going like 15, 20 miles, you could go 50 miles or 40 miles, depending how, you know, or maybe even higher. But the mileage was like really, really nice. So if you have a certain mileage, and let's say, let me just give you a sample problem. So let's say Lexi, is it with a Y or an I?
it's with an I.
Oh, with an I, okay. Okay, so this is a theoretical problem. So Lexi has a mileage. Lexi gets, let's say, you know, on the lower side, so 15 miles per gallon, 15 mpg. So you go on a trip, if you go on a trip for 45 miles away, or you just like drive for 45 miles, how many gallons does that take? So if you want to go 45 miles, how many gallons do you need to have in your tank? Or how many gallons is that going to burn out?
3.
3. So we do the distance is equal to the gas times the mileage. Or in other words, the distance over the mileage is equal to the gas that's required. Okay, so that's really the key idea to setting up the next equation. If I asked you guys, not 45 miles, but if I said we traveled for X miles, how much gas would you need to use? What do you think? If instead of 45, I use the letter X, what would the answer be? How many gallons? Anybody? So if I want to figure out how much gas I need for X to travel X miles, what do I need to do to the number X? So for this question is 3 gallons. We get 45 miles, oops, equals the gas times 15 miles per gallon. So you get, this implies that the gas is equal to, you need 3 gallons. And the gas is equal to 3 gallons. But if it was instead of 45, it would just travel some random distance. How do I calculate it? It would be, instead of 45, if it was X, it would just be X over the mileage. X over 15 is the gas. So this would be that the gas is equal to X miles over 15 mpg. That would be an expression for the gas. Please hit yes if this little example makes sense, and hit no if you're a little bit confused about it. Because I agree, like mileage is a little bit tricky to think about, but what, you know, if you think about it in the right way, it's actually pretty easy. Good, awesome. So now let's try to apply that to the next equation here that we're going to need. The next equation that we're going to need, I'll give you a hint, is we need total gallons that are required, which is going to be 23 gallons. This is total gas. Based on what we just said, what would the gas required for the city miles be? Based on kind of the same idea that we just talked about. What would be a good expression for the gas in the city miles? Anybody? Anyone have any thoughts? So for Lexi, it was X over 15. If I travel X miles, I do X miles divided by miles per gallon. That tells me how much gas I need. Nice. Lily, what did you get?
X over 18.
Excellent. And then how about for the highway miles?
X over 24, I believe.
Perfect. Or Y over 24.
Oh, yeah, sorry.
Awesome. So it's, in effect, it's actually similar. It's really similar to the Mesa College problem, but instead of being like 3x plus 4y, you have numbers in front of it that are weirder. They're 1 over 18 and 1 over 24. And that just comes from like how mileage works and what the information that they're telling us, how to set it up. But essentially, it's the same type of problem. And now you could solve this. One thing I would probably do, because I don't want to deal with fractions, is maybe multiply everything through by 24. No, maybe multiply everything through by, what is this? 6 times 3, 6 times 4, maybe multiply through by 7, like a least common multiple of 18 and 24, just to, I think 72 would work. So I would get rid of all the denominators here. That would be my approach. But if you multiply by, I think 72, yeah. So if you multiply everything by 72 on both sides, I don't know what this is going to be. It's going to be some big number. But you get, here you would get 4x, and then over here you would get plus 3y equals 23 times 72. I don't know what that is. And so you could solve it that way. All right, guys. Tomorrow, please remind me, I didn't get to go over number 35, so I want to do that. And I'll also go over some questions from the practice as well. And just a reminder that our test will be next Tuesday. I don't know exactly what day that is. What is it? I want to say that's going to be October 20th. Oh yes, submit this tonight. It's okay if it's not completed. I think we've done most of the problems. So, you know, whichever ones aren't finished, just try your best before you submit it, and then we can continue to talk about them tomorrow. But just turn it in tonight is good. All right, guys, have a wonderful rest of your day. I'll stick around here if anyone has any other questions, but otherwise I will see you tomorrow. Bye. Well done.
Bye.
See you.